In today's Executives and Dummy series, we are going to talk about LLM introduction. So here are the questions we hear about LLMs nowadays. Is the LLM hype real? Is this an iPhone moment? Are LLMs a threat or an opportunity? How to leverage LLMs to gain a competitive advantage? How to quickly apply LLMs to my data? So LLMs are more than hype. They're revolutionizing every industry. You can look at Check, for example, UChat and GitHub Copilot. Check business suffered because of LLMs. UChat and Copilot are, their products are revolutionizing the way you code and the way you search. LLMs are not that new technology. So why should you care now? Accuracy and effectiveness has hit a tipping point. Many new use cases are unlocked, accessible by all. Readily available data and tooling. There are large data sets. Open source model options requires powerful GPUs but are available on the cloud. So what is an LLM? It's a large language model trained on enormous high quality data. ChatGPT was trained on 1 trillion tokens. That amounts to around 10 million books. It can generate content. It can classify. It's a statistical model that tries to predict words. So what does that mean for you? LLMs can automate many human-led tasks. It can accelerate innovation. It can increase ROI. It can lead to faster software development. More users can leverage AI. More use cases. Reduce developmental costs. So how to pick the right LLM? There's no perfect model. Trade-offs are required. So here are some high-level decision criteria. Model quality, serving cost, serving latency, customizability. So let's do a quick natural language processing primer so that we familiarize ourselves with the basic terminologies around LLMs. So what is NLP? Natural language processing is a field of study that considers what natural language is and how can we create models and computational programs. NLP is useful for a variety of domains. Sentimental analysis, for example, product reviews, translations, for example, English to French or French to German. Question answering, chatbots, and other use cases are semantic similarity, for example, literature search, DB queries, Q&A matching, summarization like clinical decision support, news article sentiments, legal proceeding summaries, customer review sentiments, genre and topic classification. So here are some useful NLP definitions. Token, which is the basic building block. You can think of token as given a word, but generally what tokens are used in machine learning models, they're part of a word. Then there is a sequence. Like sequence is a list of tokens. For example, the moon, thousands of years, those are sequence of tokens. Vocabulary. Vocabulary is a complete list of tokens. So, but NLP goes beyond text. For example, speech recognition, there's image caption generation, there's an image generation from text. Text interpretation is challenging. Language is ambiguous, context can change the meaning, there can be multiple good answers. So input data format matters a lot. A lot of work has gone into text representation for NLP. Model size matters. Big models help to capture diversity and complexity of human language. Training data matters. It helps to have high quality data and lots of it. So what is a language model? Language model assigns probabilities to word sequences and finds the most likely next word. Its categories, the general high-level categories are generative, find the most likely next word, and classification, that is find the most likely classification or answer. So here's a language model evolution. So the language model has been, it's been existing since 1950s. So we had back of word models during the 1950s, then we had n-gram model in the 1950s and 60s, then hidden Markov models in the 1980s and 90s, then recurrent neural networks in the 90s and 2010s, then we have LSTM, which was in 2010s, and then we have transformers, which led to large language models because we could train on enormous amount of data. So here's the overall NLP summary. NLP is a field of methods to process text. NLP is useful. It is useful in summarization, translation, and classification, and other domains. Language models predict words by looking at word probabilities. Large language models are just LLMs with transformer architectures but bigger. Tokens are the smallest building blocks to convert text to numerical vectors, aka n-dimensional embeddings.